Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight we are titling this particular presentation, It's Tricky. It's tricky, just like Run DMC's song from the 80s. On the left here, I've got Run DMC. And what's so tricky? What's so tricky tonight? Well, this upcoming storm is a very tricky forecast, and on the right-hand side there, I've got rain or snow. And so we're going to take a look at some of the major critical factors in determining what is ahead, what is to come with this next storm system as it comes into the area late Sunday night, Sunday afternoon, Sunday evening into Monday. So let's take a look at things right here. Okay. The first thing I want to talk about tonight is temperatures aloft are critical to the precipitation type. And what I'm showing on this image, so I have what's known as a upper air sounding I'm showing you to start tonight's video presentation. The red line in each of the images, I have one on the left and one on the right. The red line indicates the air temperature, and the green line indicates the dew point temperature. So the dew point temperature is basically the temperature if the air were to cool to that level, to the dew point temperature, regular air temperature cooled to the dew point temperature, then you would theoretically have 100% humidity and saturation reached. In other words, you're most likely going to see precipitation when the red and the green line are really close together or on top of each other. What we're showing in these sounding pictures, this is forecasted soundings off the latest 18Z GFS model on the 6th of December 2018. Look at the red line there on the left-hand image. That is generally Saturday afternoon. Saturday afternoon, we have a cold high pressure system just pumping in colder continental polar air into the mid-Atlantic and southeast Virginia. So we have a very shallow above freezing layer, only going from the surface to about 3,000 feet above the ground. In the evening, that pretty much stays the same. The right-hand image there, the red line is generally indicating a very shallow above freezing layer, okay, surface to 3,000 feet. So Saturday is going to be very cold. We expect high temperatures in the lower 40s, most likely in the area, anywhere from 43 to 44 degrees Fahrenheit. Okay, let's move it ahead now. We move ahead now to the forecasted soundings for moving into Sunday morning and then later into Sunday afternoon. And again, Sunday morning, we have precipitation, according to the GFS forecast model, pretty much knocking on our door, about to move into southeast Virginia. The temperature is only above freezing from the surface to about 2,500 feet still. So that's not a very thick layer in the atmosphere that is above 32 degrees Fahrenheit. So most of the atmospheric column from the ground, the very bottom of the image, all the way to the top of the image, the top of the atmosphere is below freezing, with the exception of the lower 2,500 feet. On the right-hand side, we do notice the above freezing layer. When I say above freezing layer, I meaning temperatures at 32 degrees Fahrenheit, the freezing point, are higher or warmer than that, from the surface to 3,500 feet. So we do see an increase in the warm layer from the surface, another 1,000 feet by Sunday night, up to 3,500 feet. And noticeable warming occurs between the 3,000 and 4,500 foot levels, with low-level easterly winds kicking in, blowing in off the 45 to 47 degree Fahrenheit water. Okay, I'm going to talk about the importance of the wind direction here in a moment again for Hampton Roads winter storm events. All right, now we're going to move ahead to the European model. The European model 5,000 foot temperature forecast. Now, instead of using atmospheric sounding like I just showed you in the previous two slides, I'm going to just show you briefly. It may be hard to see there at home, but in general, the two images I'm showing you here for the temperatures at 5,000 feet are generally between -3 Celsius and -1 Celsius on both Saturday afternoon and night, and that's ahead of the storm. So this is really before the precipitation starts moving in and impacting our area. Okay. Moving ahead to the temperature forecast now in the European model at 5,000 feet. On Sunday, our temperatures are ranging on Sunday about +1 Celsius to -3 degrees Celsius on Sunday. So temperatures are maybe slightly above freezing, 0 Celsius, or they're most likely going to be below freezing, just slightly below freezing. That's the forecast, the latest forecast on the European model, the 12Z 6 December forecast model. And then these temperatures then warm to +2 degrees Celsius at 5,000 feet by Monday. Okay, so this is all important as far as determining precipitation type for Southeast Virginia. What are those temperatures at 5,000 feet? And here's a good example. Yesterday we saw, on December 5th here in the Hampton Roads area, we saw our first snowflakes of the season. And I mentioned this on that quick video I uploaded yesterday showing you the flakes coming down at Virginia Beach. Initially, the temperatures yesterday morning on the 5th of December, with an overcast sky, cloudy sky, the temperatures were about 40 degrees Fahrenheit in the area. Okay. Now, as an upper air disturbance moved in, it brought some rain into the area. The rain initially fell, and it resulted in a case in which there's an evaporative cooling aspect, and I'll show you an image and explain that here in a little bit. But as the precipitation falls into drier air, sometimes the atmospheric column, the area from the cloud base to the ground, can actually cool, sometimes up to 3 to 4 degrees Fahrenheit. Other cases, when you get heavier bursts of precipitation that fall from the clouds, you actually dry colder air from aloft down towards the surface. So if my temperatures at 5,000 feet are about 0 degrees Celsius or freezing, let's say, the colder air is going to be dragged down from aloft down to the surface in that case, with the heavier precipitation bursts. Now, let's take a look at elevated warm layer and precipitation types. Okay, this is just a review. If you look on the far right-hand image, I have an atmospheric column of air that is below freezing, below 0 degrees Celsius, below 32 degrees Fahrenheit, all the way from the clouds down to the ground. If that's the case, I have purely snow. Snow falls all the way down from the cloud base to the ground, does not melt. If I continually move to the left on this image, the yellow area here indicates an elevated warm layer where the temperatures are above 32 degrees Fahrenheit. And the thicker that warm air layer gets, the greater the likelihood of the snow melting into raindrops. And you see all the way over on the left, you have a deep enough, vertical, deep enough warm air layer on the far left for just rain. Okay, so you notice on the right, completely below freezing, the atmospheric sounding, completely below freezing from the cloud base all the way to the surface, all snow. On the left, you have snow maybe up at higher elevations where the cloud's at, but as that snowflake falls into that much thicker or greater depth area of warm air, it melts and turns into liquid rain. And then in between, varying degrees of elevated warm layers where the temperatures are above freezing aloft, that's where you get your freezing rain, and that's where you get your sleet. Okay, so just a quick review on elevated warm layer. When I say that, I mean a layer of air above the ground that is greater than freezing, greater than 32 degrees Fahrenheit. Okay, now this is the evaporative cooling I was just speaking about in an air column. So what happens is in some cases, the whole atmospheric column from the cloud base down to the ground can actually cool 3 to 4 degrees Fahrenheit, sometimes in the order of 5 degrees Fahrenheit. And we saw this yesterday when the rain started falling. It brought down colder air from aloft, okay, and it basically dropped our temperature from 40 degrees Fahrenheit down to 35 degrees Fahrenheit yesterday. It brought down 5 degrees, and when that happened, that rain started to mix in with those snowflakes, okay. So evaporational cooling, or dragging of colder air from aloft down from the cloud to the surface, can actually result in initially milder temperatures. You look at the left-hand part of this image, milder temperatures initially with just rain hitting the ground, and then that rain's cooling the air as it falls, and that results in colder air and a changeover from rain to snow. Okay. Now, let's take a look at the synoptic setup and the wind directions for this upcoming storm that's moving in. The image on the left here, I'm showing you a classic case of what you'd want for a winter storm in the Hampton Roads area. And this matches up with that, what's actually going to happen. The image on the left is Saturday evening, and the image on the left is Sunday morning. Notice we have a 1036 millibar high pressure system, a Canadian high pressure system. You usually get colder air with the continental polar air to the north. Okay, so you got a cold high to the northwest on that left-hand image initially at 1,036 millibars. That's fairly strong, so that's a fairly dense cold air mass. We have low pressure situated over the Gulf Coast, so low pressures to the south. Okay, so we have moisture approaching from the southwest towards the mid-Atlantic. Now the image on the right, I'm moving it ahead to Sunday morning. Notice the cold high remains to the north. All right, 1,034, it weakens by 2 millibars. Slight weakening, not much. And then you got that area of low pressure, the storm track, starting to come up the coast, but it's still to our south, right? So you're starting to see some of the moisture starting to overrun the colder air at the surface by Sunday morning. Now, the storm track is crucial. I made videos in the past. I just reshared this not that long ago, I believe around Thanksgiving. Snow factors for Hampton Roads. Take a look at that video if you get a chance. I go over the storm tracks. I go over a lot of these different scenarios on what really determines precipitation type, because it is tricky, okay? All right, so here's my questions on this, okay, the projection. Number one, how far north does the storm track go due to the positioning of the high over the top? The high's to the north. And that positioning of the high actually is preventing the storm from making a complete turn to the northeast and moving up the coast. So if you know people in the New England states, that strong high pressure system and the dry air associated with it is basically acting like a big roadblock. It's not allowing the storm to make that turn up the coast. But this is a classic situation that you typically would like for Hampton Roads to receive wintry precipitation. So, you know, if this were January, for example, we had colder water temperatures, and we have this similar situation. You know, we had a similar track like this last year for the big January winter storm that we got in the area. So this is a great setup. Cold air in place, cold air, you know, a high to the north, and the low pressure coming from the south. This is a very good setup for a wintry type precipitation event for Hampton Roads cities. All right. Now we're moving ahead now in the GFS, the 18Z GFS forecast run here. And the image on the left now shows a little bit of a northeastward turn. Okay, we still have a 1,031 millibar high situated over Long Island. So we got a high to the north. That cold high remains to the north. An area of low pressure just off the southern North Carolina coast. A lot of precipitation begins to wrap around that area of low pressure. Further inland in the blue colors is the snow. The green colors indicate the rain. So here are the questions with this, okay? This is the forecast on the left for, this is Sunday afternoon, and then by Sunday night is the image on the right. So we have area of low pressure situated off of the Carolina coast. Now, with the storm moving just off North Carolina, the wind will be strong from the northeast. So you got a clockwise flow around that high to the north. You got a counterclockwise flow around the low pressure to the south. And that is going to result in more of a northeasterly wind for Hampton Roads. And that's a problem for us, especially since we have water. If you like snow, it's a problem because you have a 47 degree water temperature, 48 degree water temperature right now. And you got if you get a stronger easterly wind component off that water, the influence of that water on modifying the air mass is fairly significant. Okay, it generally keeps that rain-snow line further away from the coast. If those water temperatures were cooler, and we're talking January, that area of snow could easily make it all the way to the coast, because now the influence of the water is not going to be as great. The modifying impacts are not going to be as great. Okay, so we in this case, the latest forecast model, which I'm showing you now, we have more of a northeasterly wind component. Okay, we need more of a north-northwest wind component to get the snow here in Hampton Roads. All right. Some of the biggest storms we've had just in the last couple of years, I've noticed a trend. North-northwest winds keep pumping in that colder continental air into the storm as the moisture rides up and over the colder, denser air. And we're going to get more of a northeasterly wind here, and that's going to result in, modifying influence on the air mass. Now, if the storm were to track due east and stay further south, if the storm track shifts just a little bit further south, or maybe it doesn't make even a slight east-northeast turn up the coast, then we could possibly have more of a northwesterly or northerly wind component and less of a northeasterly wind component, which will result in more in the way of increased likelihoods of wintry mix or snow for Hampton Roads. So again, this is an ideal synoptic setup for a wintry event, wintry precip in Hampton Roads. The question is storm track, does it change? We still have we're still a few days out from the actual storm event itself, so this could slightly change. So we got to keep a close eye on the future model runs and see what happens over the next 24 to 36 hours especially. I think by Saturday we definitely will have a lock on the storm track itself. So let's continue to move on. I wanted to show you water temperature. You have to factor in water temperature considerations along the coast for these type of events. And as of 7:12 p.m. on the 6th of December 2018, our water temperature is currently 48.7 degrees Fahrenheit. Okay, it is cooling off. It's come down slightly over the last 24 hours because of the colder air mass that's in place. We saw 29 degrees Fahrenheit this morning. We saw thick frost on vehicles. So that colder air mass is definitely chilling the water, but water takes a while to cool down. All right. Now, I wanted to show you the NOAA snow probability outlook. Okay, this is from the National Oceanic Atmospheric Administration, NOAA, and I don't know if you can see it very well, but you see these maroon colors in the center of the diagram over the Blue Ridge Mountains, the pinkish hues, the orangish hues. Those are 80, 90 to 95% probability of 1 inch or more of snow accumulating. Okay, and there is a fine line in just about 50 to 60 miles to the west of the Hampton Roads cities. The Hampton Roads cities are not in any of the snow probability graphics right now by NOAA, issued by NOAA. But we still got to watch this, because if that storm stays further south, and let's say it heads due east off the coast, then that will shift further east, okay? So we got to keep an eye on that. So now here are some considerations to ponder, okay? And these are my key points in tonight's video. Temperatures aloft will be critical, okay? We typically require 5,000 foot temperatures by 850 millibars to be at -4 degrees Celsius or colder for snow to occur. Now, you remember what we talked about back here. We looked at the atmospheric soundings, a vertical profile of temperature with height. And did we ever reach -4 degrees Celsius or lower? Let's review real quick, okay? So we had temperatures generally at this point at 850 millibars. We were sitting at about -2 degrees, -3 degrees Celsius on Saturday. And it did warm, according to the sounding, a little bit more, just about -1, 0 to -1. And we did look at the European 5,000 foot temperature forecast, and we're ranging from -1 to -3 Celsius Saturday, +1 to -3 Celsius on Sunday. But you notice no -4, okay? So that's a big consideration to take into effect. Now, if you have that kind of cold air at 5,000 feet, it's not going to take much to drag it down either. All right, so you get a heavier burst of precipitation that could temporarily change things over to a wintry mix. All right, so how heavy does the precipitation fall? That's the next question. The heavier that precip, the greater the likelihood that that colder air from 5,000 feet is going to be dragged down to the surface and drop the surface temperature even further. Okay, and that could result in a mixture of sleet or snow with that rain, especially at the start or onset of the storm. The wind direction is so crucial here, especially since we still have 48-degree water temperatures offshore. Today's models have the storm further south than 24 hours ago, which means a greater northerly wind component. I've been watching this really closely. We have a greater northerly wind component in the forecast today as compared to yesterday, 24 hours ago. And the less of an easterly wind component off the water, the less modification will occur on the air mass, and the greater the likelihood of frozen precipitation vice liquid rain. With a greater onshore easterly wind component, and what I mean by greater, a stronger wind blowing easterly right off the water, or even northeasterly off the water, if there's more of an easterly wind component, there will be a greater vertical extent to the above freezing layer aloft, completely melting the snow and making for a cold rain. Let's go back. This image right here. We're going to be situated maybe at the beginning of the storm, as the precip begins to fall within the colder air. We might be sitting where, basically, if you look at the sleet, where sleet, go straight up there and look at the yellow area there. See how thin that warm layer is aloft? We may start off like that, but if we get a strong easterly and northeasterly wind component off the water, that water modifying, the wind blowing in off 48-degree water, is going to warm the temperatures up. And that yellow stripe there might get thicker and thicker and thicker all the way to the left image there where it's rain. So your warm layer is really deep or thick at that point. So that could really happen. We may be in the sleet profile here with that little yellow strip of warm air aloft, and it might get thicker and thicker over time to where we go to rain. Okay, so that's just something to think about. If we keep more of a northerly or a northwesterly wind component with a further south track to the storm, then we could stay much colder, and that could result in more of a wintry mix for the area. All right. Now, there is definitely a threat of tidal flooding with strong gusty north and northeast winds between 40 and 45 miles per hour. They're not out of the realm of possibility, especially along the coast. The winds could be gusting up to 45 miles per hour. There's a strong pressure gradient between, we look at the setup again, synoptic setup. Cold, high pressure to the north, 1,034 millibar high, and then you're looking at about 1,009 millibar low coming up from the south. So you got, you're looking at a pretty significant pressure gradient difference there, okay, over a fairly short distance. All right, so here's my final thoughts, and this is as of December 6th, 2018, the evening, okay? Right now, it looks like precipitation will start as a rain-snow mix on Sunday afternoon, transitioning to a cold rain on Sunday night for Hampton Roads cities, all right? Heavier snow totals will remain inland towards Richmond and western Virginia, and into western North Carolina as well. The precipitation will transition back to a rain-snow mix on Monday before ending. Okay? We are not expecting any significant accumulations for Hampton Roads cities at this time. However, that could change. So that's why, again, we have to look at the factors of the wind component. Is it more northerly? What about the soundings, the vertical temperature profiles? How thick or how deep does that elevated warm layer get? Do we keep more of a northerly wind to where water is less of an influence on the overlying air mass? Do we get precipitation bursts, heavier bursts of precip that come down and drag colder air from aloft down? Okay, all factors we got to take a look at. So as of right now, the 18Z model on 6 December, this is what our thoughts are. Okay, but it is subject to some slight changes. Now, precipitation, like I said, no significant accumulations expected. We could see some wintry mix initially. And based on the latest forecast models, no significant accumulations of snow for Hampton Roads cities, as I mentioned. 4 to 6 inches of snow in the Richmond area with heavier amounts south of Richmond and then into western North Carolina are a distinct possibility with this, especially you get into western North Carolina towards the mountains. They could really get some heavy snow. We're talking 12 to 18 inches of snow as a possibility. The system is really loaded with moisture as it moves across. And the system still needs to be monitored closely. As I mentioned, that shift in the storm track, if it moves further north, it moves up the coast, further up towards Cape Hatteras, we're looking at more of a east-northeast wind component, and I would anticipate that the majority of this storm would be rain, a cold rain across Hampton Roads cities, and very minimal wintry precipitation. If it goes further south and pretty much heads straight due east off, let's say, the location of Georgia or Georgia-South Carolina border, and it kind of just skirts off to the east and heads out to sea, then we'll remain on the colder northern side of the storm, and we'll get more of a northerly wind component, less of an easterly wind component. And that may result in more wintry precip mixed in. Okay, so we need to watch this track carefully. Changing that wind direction forecast can greatly alter or change that precipitation type forecast. All right, that wraps things up tonight. Spot on weather. I wanted to go ahead and cover this storm. I find this intriguing, and this is really where, as meteorologists, we can learn, look at case studies even after storms and look at the different levels of the atmosphere. Those soundings determine what was the temperatures at, what layers were above freezing, how thick or deep were those layers, and we can take a look at all those factors. The Atlantic Ocean has a tremendous influence on our weather here in the Hampton Roads cities. So that's all I've got tonight. Spot on weather. Remember, if we're not spot on, we're not doing it right. I wish everybody a great evening. Stay tuned to Spot on Weather for the latest.